So our next, uh, before our next speaker gets set up, just a few announcements. Like yesterday, because lightning talks were like there were lots of participants and a lot of enthusiasm about it. We again have lightning talks today. Sorry. We again have lightning talks today and open space for a longer duration. Like yesterday, the boards are at the back. Today, they're marked for the lightning talks and open space. If the page gets filled, you can write on the other page. We'll have a tea break after this, and the breaks like yesterday. So like you can go right on the topic you are interested in. So our next speaker is Vishal Biyani. He's CTO of InfraCloud, which is a company based in Pune. It provides services around practices and containers and helps architect enterprise for the container support. He'll be talking around Rancher with support of Kubernetes. He has made contributions to Rancher and its integration with Kubernetes. So a round of applause for our next speaker, please.
Hey, my name is Vishal. I'm CTO at InfraCloud Technologies. We are based out of Pune. I'm going to talk about how to make Kubernetes simple with Rancher. Just a bit about myself and the company page. InfraCloud is also a Rancher consulting partner, and we wrote an ebook recently about Kubernetes, how to scale and deploy Kubernetes. It's about like a 50, 60 page free ebook. I'll just tweet it after the talk, so you can get it if you want to. Cool. So Kubernetes is coming for the fans of GOT. The way I'm structured the talk is we'll talk about problems or gaps that are in Kubernetes as of today, specifically focused towards larger enterprises and larger installations of Kubernetes. And then based on each problem, we'll go to the actual running demo and see how it solves certain things, what additional capabilities you get out of Rancher, basically. So Kubernetes is a fairly complex project in the sense you have multiple components stitched together. And setting it up from scratch is not trivial. It requires some work. And if you're managing multiple setups, fantastic, even more difficult or complicated work you got to do. We'll see how it is simple to set up the cluster here. Hold on. You can't see the browser, right? Okay, that's weird. Okay, that's right. Cool. So this is the Kubernetes window. It's looking rather weird, actually. Abhishek, do you know how to configure the resolution for this? Okay, that's way better. Cool. So we'll quickly set up one Kubernetes cluster, new cluster right here. And while it sets up, we'll go through rest of the topics, and then we'll come back to see the completely set up cluster. So basically, you have environments, and one environment is equivalent to one cluster, so to speak of. So I already have one default cluster and one K8s cluster. I'm going to set up one additional cluster, and we'll let it go while we...
Sorry, Vishal. Can you please increase the font size? It's not visible to the folks at the back.
Sure. Is it better?
Yeah.
Cool. So I'm going to say add an environment. So the good part here is you can not only manage Kubernetes, you can also manage Mesos clusters or a Swarm cluster or a Cattle cluster. So Cattle is their own orchestrator from Rancher. So you can manage more or less all the orchestration engines through Rancher. So I'm going to create a new Kubernetes cluster and call it DevOps days. So I have my the object kind of created here. I'm going to switch to that context now. So everything you talk about in Rancher is in context of an environment. So now I'm in DevOps days environment. And now I'm going to go and say add host, because yeah. So I'm going to add my host. So I'm using DO to create a few hosts. So this is going to create a complete cluster, set up the Kubernetes master for us, and on each of the nodes, also set up Kubernetes agents or kubelets, basically, and that's going to take some time, so we'll come back to that. And I'll switch the clusters back to K8s, basically. Cool. So yeah, the bonus point is you also get to manage other clusters other than Kubernetes. So we'll quickly also see what components are there when it really sets up the cluster. So if I go to system, I can see the whole Kubernetes stack that has been set up for my previous cluster. So you see basically the controller manager, the etcd cluster, kubectld, proxy, and then there are some additional components like rancher ingress controller and rancher Kubernetes agent, which help you do things which may be not possible in Kubernetes or still not built as of now, basically. You can also see that if I go to system, I see two more tabs or sections for ingress and load balancers. So when I deploy a new service tomorrow and it has a load balancer, it's going to create a load balancer over here. So can I just not? Okay, I have to always make it small and okay, come here. Sorry. Yeah. So here is the Kubernetes cluster with all the components of Kubernetes, etcd, controller manager, API, proxy, and stuff. And if I look at system, I also see the ingress that I have created if I have any, and load balancers if I have any. The load balancers that it can create, if you want a software version, it's an HA proxy. It can also integrate with underlying cloud load balancers like ELB or in Google Cloud, whatever is the load balancer, basically. So now the next question is, I have created my cluster. I want to give access to it to certain people, right? I want to give certain level of access to developers, certain level of access to my junior ops guys, and I want to keep, let's say, the highest possible access with me, right? So how do you manage access? I don't think Kubernetes has a native way of managing like a role-based access control, and Rancher basically provides that. So you have basically four kind of roles: the owner, member, restricted, and read-only. And based on what user or what role has been assigned to you, you get different levels of access in different areas of Rancher, basically, infrastructure, applications, and stuff like that. And these are managed at environment level, meaning the environment that we just created DevOps days. You can create like a number of users, or you can integrate with LDAP, and then assign a role to individual user that he can only do certain number of things, basically. Now the next part is your cluster is up, you have given access to people. You want to see what your cluster looks like, where are your hosts placed, what kind of containers are running, which container is running on which host, and did somebody move my container from X place to Y place, and what memory, CPU, and other matrices I want to look at, right? So if I go to infrastructure, I see a few things. So for example, if I go to host, I can see all the hosts that are part of the cluster right now. I can see that one cluster had some error while provisioning. I couldn't install Docker for whatever reasons. And other nodes of the cluster are up and running, basically. I can actually click on the individual host and see further details, what kind of config it is, what IP it is holding at the moment, how much is the CPU memory consumption of that host, and what Docker version, et cetera, et cetera. You can also see the containers, the ports that are in use, and the volume or the storage that has been attached on that host, basically. It's a bit slow, so it's taking time to load. Let me just do refresh quickly. Okay, I'll switch my Wi-Fi to the other one. Yeah, so yeah, I can see all the details of the containers, and further I can drill down to containers also, look at what kind of CPU memory and stuff, on the containers basically. On the containers also, you can see the volumes that have been attached, the ports that have been exposed as part of the definition that you have deployed, right? So all the basic matrices, not definitely detailed application level matrices at the moment, but yeah. One good part here is the labels. So the way you have labels in Kubernetes to decide, or let's say I want to filter all my web servers or all my database servers. Labels here are a lot more advanced. You can actually define certain labels to do certain things. For example, for certain applications, I want to say the image should be always pulled from repository no matter what. And I'm sure there is an equivalent in Kubernetes. But then there are other labels which can do a lot of interesting things. For example, tell it to look at certain DNS and not look at certain DNS and things like that. So labels can be configured as definition of the manifest, which I'll show a bit later. And some labels are put by system itself to manage the whole thing, basically. Cool. Sorry about the interruption. So we looked at the host matrices, the container matrices, all through the UI. Of course, there is an API. We'll talk about it again in a bit. More infra. So how do I set up DNS? In Kubernetes, DNS is not built in as of today. We have to use something like Sky DNS. Things like load balancing, and can I do some metadata-driven infrastructure, basically. So load balancer is built in here in Rancher. It's a HA proxy, basically. And the DNS is again built in, so you can actually use the pod name to reach out to the pod directly. So probably let's do a quick, so I'll talk about load balancer when we actually deploy one sample application. So the next question is, how do I deploy apps, right? How do I enable my development team to do app deployment without having me to be involved every time they want to deploy apps, right? And same goes with the platform. Like, do I give access them only to deploy apps like microservices, or do I also give them access to set up things like Elasticsearch or some base platform on top of the bare OS, right? And how can I enable this at a larger scale? That's the basic problem. So that's where I think one of the very interesting features, which is probably also present in similar products, is called as application catalogs. So if I go to application catalogs, I can see all the apps that are available as my organization. And I can say, let's say I want to launch guestbook, right? I can say view details. So it tells me there are just one version at the moment. And it asks me certain details before I spin up. So I can decide, let's say I want 3 slaves or 2 slaves or whatever. And then I say launch, basically. So when we say launch, it actually goes and launches all the required services and replication controllers and pods, of course. So you can also see that it has also created a load balancer for the front end. It's still pulling the containers for that. And then equivalent load balancer has been created in the system, basically. So this is the equivalent load balancer for the guestbook service. And my service is up and running, basically. So I can say hi from DevOps, right? Right? Looks like database is not yet up, so, or the cache Redis is not yet up. So holding on to that. So now the interesting part is, how did this happen, right? So what is the thing that is running behind this? So if I go to, again, the guestbook app and say view details. So before I launch, I can actually do a preview of what manifest file it is using. So you can see the replication controller, the service files and stuff. But you can also see some things are parameterized. And these parameterized files is what is governed from Rancher Compose, basically. And this is what is taken as an input from the user. So you can customize this file as much as we want, take whatever inputs from the user, and then accordingly launch that cluster based on the user requirements, basically. And these manifest files are our old, usual, simple Kubernetes manifest files. They're not any different. It's just that they're parameterized. In fact, if I go and create a new service in command line from Kubernetes control command line, it'll actually reflect that in Rancher as well. So again, we'll go in slightly more detail on this. So all the catalogs are available on GitHub. So the way it has been structured is within a given stack, like Kubernetes, you have multiple templates. So let's look at the guestbook one, right? So you have the config.yaml, which is just a basic information about the catalog or the application, and then the PNG, which is what the image you saw in the window. And this is the 0th version of this catalog. So let's look at Rancher Compose first, and then let's look at the other ones. So Rancher Compose is what forms your questionnaire when you launch a catalog. You can say, I want X number of instances, I want to be running them at export and all that stuff. So these questions are configured here. And then the same names can be used as parameters in actual replication controller or deployment or service YAML files, basically. And this format is exactly the same as Kubernetes native format. Or if you're launching it in a Mesos cluster, it is Mesos' native format, which is Rancher Compose. It is not any different, basically. So that's the structure, and that's how you launch basically apps. So you can imagine if you have, let's say, 20 or 100 or 150 developers, and the kind of enablement that you can do by exposing the UI, and they can really self-service themselves. Now, a couple of other things, right? Like, I want to integrate my private registry. I don't want to use Docker Hub. Or things like, my data scientist asks me for a new cluster every 3 weeks. He wants to do some mathematical modeling and stuff like that, right? And then lastly, how do I track all this? Like, who has done what kind of activities? So for auditing purposes or for reporting purposes, basically. So let's look at those. So you can actually configure private registries as well here. So I can say add registry. The Docker Hub private and QA is by default configured, and custom can be any private registry. It will work because the protocol or the APIs are the same, no matter what registry you will be using. We can also look at audit logs. So audit logs gives you an idea of which user has done what or what resource basically. So it's all up there. Accounts, again, you can configure either using LDAP, or you can have a local database, or you can configure GitHub as the authentication module and then give access on the users, basically. Right. And yeah, so while we're talking about a data scientist cluster, let's also try to launch, let's say, a Spark cluster. So this is a Spark cluster I'm trying to launch. I just said worker replica count 1. Let's do a quick preview. So it's going to launch a Spark master, a Spark web UI, a Spark worker controller, and then Zappelin service as well. So let's go ahead and do launch. So that will take some time, and we'll continue on the slides. Then comes the question of certificate management, right? I want to also manage certificates, like some applications require HTTPS certificates and keys and whatnot. Can you also integrate with APIs so that you can extend and not necessarily use this UI, but use something that you already have, like Jenkins or some other CD tool, to integrate and do the same things that you do in UI, basically. And storage and stuff. So one of the things is we are using 1.1.4, which is actually using Kubernetes 1.2. And the next version, which is 1.2, will have Kubernetes 1.3 support. So at the moment, if you look at the storage, it's pretty much blank. But the next version that is being built has storage for your cloud-based storage providers. It can be EBS or Google Disk or OpenStack or whatever. You also can manage certificates here. So if you add a certificate, you add all the details here. And then when you're configuring an application or a service, you can actually say, I want to use this certificate. So once I have configured the certificate here, and if I go to system, and I say I want to create a new load balancer, I can actually say SSL here, and it will give me an option to choose certificate right from here, basically. While we are talking about load balancer, it supports both like L3 and L7 load balancers. So you can really define custom routing and stuff. Advanced routing options. So you can actually define to go, so let's say you want to direct the payment, get like payment related request only to certain pods, and let's say checkout related request only to certain pods. So those kind of things can be done here as well. So it is all HA proxy eventually in the background, but it's pretty powerful. You can also custom paste your HA proxy config and just go from there. So let's see if I have, our cluster has been created. Let's go over that. Okay, looks like it is up. Yeah, all things look good here. So I have also integrated sysdig with this. So I actually did sysdig catalog, and I launched it from here, and I can see the matrices of that in sysdig also. So you can see again host level matrices, container level matrices, and stuff like that. A lot more detailed, of course. We also have Prometheus catalog, which we recently wrote here. Then Prometheus also we can launch and look at that basically. Also we covered the cool, and I was talking about labels, right? So these are some of the labels that Rancher provides, which will define what can you do with those labels basically. For example, you can say start once. If it fails, don't start again. Don't just try to repeat and things like that. Yeah, that's pretty much about Rancher and how we can use Rancher to make Kubernetes easy. Any questions, doubts?
Any questions?
Hi. Could you compare OpenShift with Rancher?
Sure. So I think OpenShift gives a lot more bells and whistles in terms of you have like the build system built into it. You have the registry of Docker containers also built into it. I think there is scanning also available in the latest version of OpenShift, if I'm not wrong. So it kind of builds a whole ecosystem for developers, if you have to say it that way. But Rancher, I would say, is more like a orchestrator neutral platform. If you have, like, say, multiple clusters to manage, Mesos and Kubernetes and Swarm, this is probably a better solution. And also, if you want to manage multiple clusters, like I have Kubernetes clusters for, let's say, one business unit, second business unit. Within that, I have one for dev, one for QA, one for stage and production. So that's probably is better managed here. Again, I don't know OpenShift like to real depth, so to speak of. So that's my judgment so far.
So you have been talking about developers often. So who is the target audience for this? Is it inside the corporate, like inside a big company where there are a lot of business units? Is it for the developers, or is it to host the apps to the outside world as a service or as a platform?
I would say both. Like a large organization having large development teams will definitely benefit from this. In the sense, you can really give assign infrastructure to teams, and they can play with that while you manage everything in a central window. But people are also using Rancher to actually expose services to outside world, like consumer-facing apps. Like Rancher has publicly referenceable customers like Disney and Amex that I know of, and they actually are using Rancher in production for public-facing services as well.
And is it like a PaaS offering, or is it on-premise software?
So there is no like web or cloud-based version. It's only a binary that you go and install wherever you want, a Docker image basically. So you can install in AWS or Google Cloud or on-premise or whatever.
Okay, thank you.
Anyone else? Okay. Thanks, Vishal. Maybe like people who are interested in OpenShift versus Rancher, they can go and suggest a topic for the open space. Yeah. So now we'll break. There'll be a tea break for around half an hour.